All right, so introducing the shadow DOM again. We'll go into we're going to go into the shadow DOM a bit here and talk about how it works and how we can get modularity with web components in a native fashion. We have these problems with CSS that are inherent in the technology. No scoping, no organization, everything is global, and that's problematic. And patterns help, but they're just convention. When I was walking around and talking to a few of you, the question was, isn't this just like naming convention? Like, yes it is. That's the point. That's problematic. It's not supported in the technology. So we sort of find workarounds for it, and that's fine. The workarounds work, but they're not enforced. We have to kind of use the tooling if we really want support there. But nothing is truly modular. Nothing is really natively modular, and those still leak. Like, they still leak to some extent. You can try to scope, but there's still going to be problems in nesting in particular that really can't be prevented. And that's until now. The shadow DOM and web components change this. So we're about to enter a new dimension, cross over the shadow boundary into the shadow DOM. So shadow DOM support provides APIs for DOM tree encapsulation. This is what the shadow DOM is. It's DOM tree encapsulation. Now DOM here, right, means HTML, but that also means we have encapsulation and scoping for our CSS. I'm going to show this demo that we showed yesterday. The video element is this native HTML5 element, and that's really cool. But if we go ahead and turn on user agent shadow DOM in Chrome, we can tell that it's not one big thing. It's actually a whole bunch of different parts. And we can actually see that the browser has used shadow DOM here to implement inputs and text nodes and divs within their actual element. That what at first glance seems like one element is actually multiple parts. This is enabled by the shadow DOM. And you'll notice, again, when you open up your browser, you'll see shadow root here. And that's how we know that this new DOM tree is within the shadow root. All right, so what are the kind of key commands that we need to know for shadow DOM? Element.create shadow root is the big one. So element.create shadow root, remember that. If you're going to remember how to use shadow DOM, it's element.create shadow root. Then we access the shadow root on an element that has one with element.shadow root. So this is a property that we can use to access that shadow root. And these are both in JavaScript. So what's happening here? We have our document tree. This is the DOM. It's the object in the browser with the nodes that are the elements on our page. A tree is a data structure, right? It sort of looks like an upside-down tree if you flip it over. So if you're familiar with trees as data structures in computer science, that's what these are. This is an ordinary document tree. This is ordinarily what you have with all your elements in your browser. You have child elements. So you have a root element, right? You might have your body element or your HTML element. And from there, you have child elements. You might have divs and links and images and all sorts of things. And that goes on and on and on. This is a very small tree. Well, when we have the shadow DOM, one of these nodes becomes a shadow host. So this is going to be a host for a shadow tree. So when something becomes a shadow host, that's when I call element.create shadow root. Now that element is now a shadow host, still in our main document. Now we get this shadow tree. So when we create shadow root, it creates a new node that will be at the root of a new tree. So the shadow root is now going to be in our shadow tree. And the shadow root now can have its own nodes here. And I can actually go ahead and within my shadow tree have another node that can create a shadow tree as well. So we have this idea of the shadow DOM and the light DOM. The light DOM is the normal part of the DOM, the everyday DOM that we're used to. It's the normal nodes on our page. And then we have a boundary, the shadow boundary. And then we have the shadow DOM. And those are the nodes that are children of a shadow root, or shadow root and its children. And so when we talk about scoping in CSS and DOM tree encapsulation, it's important to have this sort of image in your mind. The light DOM on one side and the shadow DOM on the other. And the shadow boundary. All right, so adding some HTML. Once I have a shadow root, I want to put HTML into it. I want to add some nodes underneath, otherwise the shadow root's going to do nothing, it's just there. So the HTML to do this, I have my shadow root with create shadow root, so I have document.querySelector element shadow. This is going to be my shadow host. Then I call create shadow root. That's going to return a shadow node, so now I can say shadow root equals, and that's my shadow root. I could also access it with querySelector.shadow root once I created it. Then I can set my inner HTML of that node. It's just an HTML node, so I can say shadow root.inner HTML plus equals add to the current append to the current HTML and add a new paragraph in there. And that's going to add it to the shadow DOM. How can I do styles? Well, I can do that the same way. I can append to that shadow root, but I can append a style element. And this is how I'm going to be able to get styles within my shadow DOM. CSS doesn't cross the shadow boundary in either direction. So my styles aren't going to leak out in terms of the rest of the document, and my styles in the document aren't going to leak into my shadow tree, unless we explicitly do it. So in yesterday's demo, we saw that by default, these styles didn't leak between the boundary. We can actually cross that boundary, and there are a few different ways to do that. So we can go into the light or into the dark. And so that's how you want to think about these new methods in CSS. We want to categorize them by into the light, which means you're going from your shadow DOM and you want to change the styles in your light DOM, in your main document, or you want to go the opposite direction. You want to go from your main document and change the styles in the shadow DOM. So that's how we categorize these. So into the light. We're in our shadow DOM, but we want to select that host node. We have a pseudo class for that host element. Colon host, this is CSS, colon host, curly brackets, and we can do our styles here like normal CSS. Now, again here, remember this, right? Our shadow host is just hosting our shadow tree, so that's still in the light DOM. So if you want to style that host, you need to go from the shadow tree into the light. All right, another into the light, we have host context. This is what we call a functional pseudo class. So it's a pseudo class in CSS. We know that because of the colon at the start here. But it's a functional pseudo class, which means we have these little parentheses at the end. And so within those parentheses, we can put a selector argument. And it's an argument like in JavaScript, but it's a CSS selector. And so that means that these styles will only be applied if for the host element, for the host, if the parent matches that argument. So here I could pass in .active, for example, into my host context, and that would apply if my host node has a class is active. Does that make sense? All right, these aren't used as commonly, but they can be useful. All right, another one into the light. We played around a little bit with content earlier. I'm going to go more into it later. But content is in the light DOM. So these are for accessing distributed elements that are rendered via our content element. And to access these, we have a pseudo element. It's a pseudo element because of the two colons there. So we have a pseudo element for distributed elements rendered via content. And this will access those content nodes. Again, we'll talk more about content later. But content allows us to take content from the light DOM and project it into our shadow DOM. All right, let's go the other direction. Now we're going into the dark. So we're in our light DOM, in our document, and we want to select something in the shadow DOM. We have a pseudo element for shadow root. So pseudo element, again, 2 colons, shadow. This means that any styles here, it will apply to a shadow root that I've specified. So you would usually use this selector with another selector right here. So I would do dot shadow host, or whatever my host element was, colon colon shadow. That's going to get me the shadow root within that host. And now I can modify that. So now I've crossed the boundary into the shadow DOM. We also have this deep combinator. Now this looks really weird in CSS. So a combinator in CSS is anything that goes between two different selectors. So you could sort of imagine here, I could change this, right? If I had my component, and then I had foo, if I put a greater than symbol, let me zoom in here. If I put a greater than symbol here for a child selector, that's my combinator, right? It means I can combine things, so I can combine two selectors. So that's a combinator. We have other combinators, like siblings. Probably the most common, though, right, is that we have as a symbol is the greater than. Well, with shadow DOM, we have a new one called /deep/, which I think is a terrible way to write a combinator, but that's how we did it. So /deep/, and this means ignore shadow boundaries. Ignore shadow boundaries and just go straight through them. There was a proposed change, and I don't know if it was actually ever implemented, to change this to greater than, greater than, greater than. And I think that's a little cleaner. But it basically means that if there's a shadow DOM, shadow boundary in between body and P, we're just going to ignore it. And we can go right through shadow boundaries, and we can break that encapsulation. In the scoping module draft for the actual spec for this CSS, for the CSS spec, there was a great comment, I thought, that deep is basically a super descendant combinator. Like we have our combinator, our descendant combinator, right, if we just have a space here. It doesn't illustrate very well because it doesn't look like there's anything there, but the fact that we have a space means it's a descendant combinator here, and that we select anything foo that's a descendant of my component. Well, it's basically a super descendant combinator. It's that any descendant, right, and ignore any shadow boundaries, even though descendant selectors normally don't ignore shadow boundaries. They normally stop there. So the triple greater than or the /deep/ ignores them altogether. You might be thinking, like, doesn't this defeat the whole purpose of shadow DOM, right? Now we can just break through, like, you just put deep everywhere. Other people agreed. There was a lot of controversy over this selector, this combinator. And so I think it's an IRC log or a transcript from a discussion between some of the stakeholders at different browsers discussing whether this was a good idea. And they got to the resolution to remove the shadow piercing combinator. I think this happened in April. I don't know. I didn't actually put a date on this slide. But this passed, a couple of months ago. So goodbye, deep. I had the whole series of slides because it's really interesting. And actually, whenever I've given a web components presentation before, this is always a big piece of it. This is deep. This is how we break through the shadow boundary. And then I saw this. I'm like, oh, it's not going to be there anymore. But it still works. In Chrome, it still works, so we can still play around with it today and see how it works. But just don't get too attached, because it's likely going away unless something changes. So why is this important? Shadow DOM means styles are no longer always global. We can actually have a way to make styles that are scoped specifically to our module. It means that the DOM can be encapsulated. We can hide all the messy stuff underneath a shadow root, and we don't have to have all these divs and different HTML elements in our components that we really want to hide from anyone who has to use our component. We can scope our styles. We can actually scope styles to particular modules and be very clear about that. And we can organize them too. This also gives organization that we didn't have with the patterns. We now no longer have to be so concerned about prefixing our selectors with like media object underscore underscore. Like, it doesn't really matter because those styles are only going to be applied within my shadow root. So I don't need to prefix them. I don't need that sort of artificial organization that I had to get with patterns. And order also doesn't matter. Like, I can pull in one DOM node with shadow boundaries and styles, another DOM node with shadow boundaries and styles, and the styles aren't going to bleed between them, so it doesn't matter what order they're going to be in. Order still matters within my shadow node, so if I have a style element within my shadow node, then certainly the selector still, the order still matters there. But it's sort of like hitting the reset button. Sort of like, you know, I've gotten to a shadow boundary, oh, start all over again, and this is like I had a blank canvas for my, my module. And I think this allows us to think about our components at a lot smaller scale. And when we talk about the challenges with CSS, we usually talk about them as being problematic at scale. That CSS really becomes challenging as applications become more complex, as you're working at, on bigger applications, bigger organizations, and you have lots of CSS and you don't know about the conflicts. But it's not actually that hard on a very small scale. And so if you can sort of cut it out, if you can bring it down to a bite-sized piece, I think that makes it easier to reason about and easier to work with. So we're going to dive into some exercises.